Your dryer is full of invisible forces that have nothing to do with heat. Every time you open that dryer door, something strange has happened. Your clothes have clustered together like they're glued. A sock clings to a shirt. A towel wraps around a pillowcase. You pull them apart and they resist almost playfully. But this isn't magic. It's not even complicated. It's electromagnetism at work in the most mundane moment of your week. So why does static cling happen at all? The answer starts with atoms. Every atom carries a balance of positive and negative charge. Normally, they cancel each other out. But fabrics are different. When two materials rub together, cotton against polyester, nylon against wool, electrons jump from one surface to the other. This happens constantly in your dryer. Thousands of pieces of fabric tumble and collide. Each collision is a tiny theft. Electrons migrate. One fabric becomes positively charged. The other becomes negatively charged. They're no longer balanced. And imbalanced things want to balance themselves. Here's where the mystery deepens. Opposite charges attract. It's one of the most fundamental rules in physics. A positive sock and a negative shirt are now attracted to each other. They pull together. They cling. And the hotter the dryer, the more vigorous the tumbling, the more electrons get knocked loose. Heat accelerates the chaos. But wait, there's something else happening here. It's not just attraction between two pieces. The charged fabrics also attract the air around them. Moisture in the air, humidity, gets pulled toward those charged surfaces, and moisture is a conductor. It allows charge to dissipate. This is why static cling is worse on dry days and gentler on humid ones. Synthetic fabrics make this worse. Polyester, nylon, acrylic, these materials don't absorb moisture the way natural fibers do. Cotton and wool can hold water. Synthetics repel it. So when you run a dryer full of polyester blends, you're creating the perfect storm: friction, heat, low humidity, and fabrics that can't shed their charge. This is why dryer sheets exist. They're coated with a wax-like compound. When they tumble with your clothes, they transfer that coating to the fabric surface. The wax is conductive. It allows charge to flow away. The clothes don't build up imbalance. No imbalance means no attraction. Static cling vanishes. But here's the deeper insight. Static cling reveals something profound about how the universe works. Electromagnetism isn't just something that happens in dryers. It's the force holding atoms together. It's what makes light. It's what allows your phone to work, your body to function, the sun to shine. Every interaction between matter involves charge. The ancient Greeks noticed static cling. They rubbed amber with fur and watched light objects jump toward it. They didn't have the vocabulary for electrons or charge, but they saw the effect. They called it electron, the Greek word for amber. That's where the word electricity comes from. A laundry mystery that's thousands of years old. So the next time you open your dryer and find your clothes tangled together, you're witnessing electromagnetism in action. It's not a nuisance. It's evidence of one of nature's most elegant rules. Opposite charges attract, like charges repel, and everything, from the smallest atom to the largest star, follows these laws. The everyday mystery of static cling isn't really a mystery at all. It's physics, and understanding it means understanding something about how the world is built. Subscribe so you don't miss the next ordinary moment that reveals something extraordinary about how things work. Subscribe so you don't miss the next ordinary moment that reveals something extraordinary about how things work.